Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes. In last lecture we have discussed about what is relation between linear acceleration and angular acceleration. Okay. Now we will see next topic, which is equations of rotational motion with constant angular acceleration. See, in chapter number 3 we have derived equations for uniformly accelerated motion in one dimension. In chapter number 4 again we have derived equations of uniformly accelerated motion in plane. Now in this chapter it is again equations of constant angular acceleration, but it is for rotational motion. See, we are assuming let at time t is equal to 0, angular position is theta is equal to 0, or I can say this directly 0, and angular velocity is omega 0, and at time t is equal to t, its angular position is theta and angular velocity is omega. Simple. So yes, at time t is equal to 0, angular position means it is initial angular position, initial angular velocity. At time t is equal to t, final angular position, final angular velocity. Now, if axis of rotation is fixed, we can say omega, omega 0, alpha, they all are in same direction. Okay, so yes, if axis of rotation is fixed, we can say omega, omega 0 and alpha are along axis of rotation. Okay, now how to obtain such equations? So simple. First of all, we will start from definition of acceleration. It is constant angular acceleration. So for constant angular acceleration, we know that average value is equal to instantaneous value. So yes, here I will use equation of instantaneous. Okay, the angular acceleration alpha is equal to delta omega upon delta t. So therefore alpha is equal to delta omega, change in angular velocity, final angular velocity omega minus initial angular velocity omega 0 divided by t minus 0. So therefore it is alpha is equal to omega minus omega 0 upon t. Now if you take alpha this side, it is alpha t is equal to omega minus omega 0, and therefore omega is equal to omega 0 plus alpha t. Clear? It is first equation. And yes, it is similar to equation v is equal to v0 plus at. Simple. So it is first equation. How to derive this equation? Okay. Now second equation. How to derive second equation? We know one definition. That is angular displacement. Angular displacement is equal to average angular velocity into time. Yes, you know this definition. Okay, you know definition of average angular velocity is angular displacement upon time. So yes, here angular displacement is as subject. Displacement means changing position, means final position minus initial position. So it is final position minus initial position. Theta minus 0 is equal to average angular velocity means omega 0 plus omega divided by 2. Initial angular velocity plus final angular velocity divided by time into time, that is here it is t. Simple. Okay, so therefore theta is equal to here I have to put value of this omega, which is omega 0 plus alpha t. So it is equal to omega 0 plus this omega, I have to put its value, that is omega 0 plus alpha t divided by 2 into t. Okay, so therefore theta is equal to, see how to simplify this, omega 0 plus omega 0, 2 omega 0 into t, 2 omega 0 t divided by 2 cut, so it is only omega 0 t plus alpha t into t, alpha t square divided by 2 means it is half alpha t square. So yes, it is second equation. Yes, it is second equation. Okay, and which is similar to x is equal to v0t plus half at square. Simple. So it is second equation. Third one, how to obtain third equation. How to obtain third equation. See, it is easy again, okay? How to obtain third equation. See, here it is. I will again use this definition. That is, angular displacement is equal to average angular velocity into time. Means theta is equal to omega 0 plus omega divided by 2 into t. Now see, from this equation, yes, this equation, make t as subject. So if you make t as subject, it will be omega minus omega 0 divided by alpha. So put value in this equation. So theta is equal to, it is omega plus omega 0 divided by 2. T is replaced by, from here make t as subject, then it is omega minus omega 0 divided by, yes, it is alpha. Okay, so see, this 2 alpha, this in denominator. If I take this on opposite side, it will be in numerator. So here I can write this, that for 2 alpha theta is equal to omega plus omega 0, omega minus omega 0. So yes, I can write this omega square minus omega 0 square. It is equation number 3. And yes, it is similar to 2ax is equal to v square minus v0 square. Simple. Okay, so yes, these equations are for rotational motion. The equations for rotational motion with constant angular acceleration. Method is similar to which we have obtained in chapter number 4. Clear? Okay, so yes, you have to remember this each and everything. Okay, now yes, one note. Okay, how to find angular speed? How to find angular speed, angular velocity. Angular velocity, its equation is omega is equal to, it is d theta upon dt. Where what is d theta? D theta is change in angular position, and dt, that is time. Now whenever particle performs circular motion, so for that circular motion, we know that for one rotation means, for example, it is circle. If particle is starting from this point, means angle is 0. Now 90, 180, 270, and here it is 360. Or in terms of radian, here it is 0, pi by 2, pi, 3 pi by 2, and 2 pi. So what is change in position? Yes, initial position is 0, final position is 2 pi. So 2 pi minus 0 is equal to, it is 2 pi. So yes, you have to remember, okay, for one rotation, angular displacement is 2 pi radian. For one rotation, angular displacement is 2 pi radian. Simple. For one rotation, angular displacement is 2 pi radian. Okay. And what is time? It is nothing but periodic time. That is capital T. Okay. So yes, for circular motion, for one rotation, if you want to find omega, that omega, what is its equation? Omega is equal to, it is 2 pi upon t. It is radian per second. Okay, so yes, remember this equation. Remember this equation. Clear about this? Okay, so yes, these equations you have to remember. Now we will see one question based on this. Now next is one example. See, the length of second hand of clock is 20 centimeter. Find angular velocity, linear velocity, angular acceleration, radial acceleration, tangential acceleration, linear acceleration for the particle at tip of second hand. See, for example, it is clock and here it is second hand. It is its tip. Okay, yes, it is its tip. So see, the length of second hand of clock is 20 centimeter, means it is nothing but its radius. Yes or no? So yes, here radius r is equal to, it is 20 centimeter. Clear? Okay? Okay, so radius r is equal to, it is 20 centimeter. First of all, you have to find what is angular velocity. First question, angular velocity. Angular velocity omega is equal to, see again, this particle at tip or second hand, it will perform circular motion. Yes or no? This second hand is performing circular motion like this. Okay, now? So yes, it is performing circular motion. So yes, for circular motion, what you have to use? It is angular velocity, means it is 2 pi upon t. Now 2 pi, if I am taking one rotation, then angular displacement is 2 pi and time is t. Now 2 pi divided by t. T means what? Periodic time. This second hand of clock takes 60 seconds to complete one rotation. Yes or no? Yes. Second hand of clock takes 60 seconds to complete this one rotation. So yes, here as t for second hand, t, that is time to complete one rotation, is 60 seconds. Okay, so yes, this point you have to remember. Now you can see, you have to put t is equal to 60 seconds, so it is 2, and here it will be 30. So it is pi by 30 radian per second. It is pi by 30 radian per second. First question, simple. Angular velocity omega is equal to, it is 2 pi upon t. T, that is periodic time, means time to complete one rotation. Second hand takes 60 seconds to complete one rotation. So it is easy. Second, linear velocity. Linear velocity means v. Linear velocity means v. Okay, angular velocity means omega, that you know. V of the particle at t. So from this axis of rotation, this particle is at distance r. So its linear velocity v is equal to, it is omega. What is value of omega? Here it is pi by 30. Here it is pi by 30. Into what is value of r? It is 20 centimeter. It is 20 centimeter. So yes, it is 1 0 cut. So it is 2 pi by 3 centimeter per second. Why centimeter per second? Because this radius is given in centimeter. Okay, so yes, linear velocity is simple. Next one is number 3, that is angular acceleration. Angular acceleration means alpha. Angular acceleration means alpha. Now see angular velocity. Angular velocity pi constant, 30 constant. Yes or no? Angular velocity of this second hand is constant. Okay, yes, its speed is maintained constant. You have experienced at some times second hand is moving slower, sometimes it is moving faster. In due to temperature differences, due to season differences, okay, due to place difference. Is there any change in speed of the second hand? No. No, it is moving with constant speed. It is moving with constant speed. Yes or no? Yes, it is. Okay, so yes, angular acceleration, okay, as angular velocity, omega is constant, is as angular velocity omega is constant, therefore angular acceleration alpha is equal to 0. Alpha is equal to 0. Okay. Next question, number 4. Radial acceleration. Yes, what is radial acceleration? Radial acceleration means AR, and AR, its equation is AR is equal to, yes, you have 3 equations. AR is equal to, it is omega d is equal to omega square r is equal to v square upon r. Yes, you can use anyone. You can use anyone. If you want to use, it is omega d. So yes, we will use this equation, omega into v. Where is omega? Here it is pi by 30. Here it is pi by 30 into what is v? Here it is 2 pi by 3. Here it is 2 pi by 3. Clear about this? Okay. So yes, here it is 2 means it is 15. 15 into 3 means 45. So it is equal to, it is pi into pi means it is pi square divided by 15 into 3 is 45. And as it is acceleration, it is centimeter per second square because it is linear acceleration. Clear? So AR is equal to, it is pi square upon 45 centimeter per second square. Simple. Yes, you have to remember this equation only, that is AR is equal to omega v. Clear about this? Now next question. Now next question is, you have to find tangential acceleration. Yes, tangential acceleration. Number 5, yes. Tangential acceleration. Okay, tangential acceleration is AT. And you know equation of AT. AT is equal to, it is alpha r, but alpha is equal to 0. R it is 20, so it will be 0. So tangential acceleration is 0. Okay. Now last one is, that is number 6. Okay, what is linear acceleration? Linear acceleration. Yes. Equation of linear acceleration is A is equal to AR plus AT. Means A is equal to under root AR square plus AT square. But AT is equal to 0. So we know that A is equal to AR and AR is equal to, it is pi square divided by 45 centimeter per second square. So it is its answer. Okay, so yes, it is one easy question which is based on equations. That you have to remember. Now you have to find same question, okay, with same data, just one thing changed. The length of minute hand is of clock is 20 centimeter. Then find the respective questions. Simple. What I have changed, second hand is replaced by minute hand, and third question, that is hour hand. Okay, so yes, you have to solve 2 questions. What will be changed? T. This T. For second hand takes 60 seconds to complete one rotation. In comment box you have to write time required to complete one rotation by minute hand and by hour hand. Clear about this? Okay, and yes, it is one example which is based on the equations that we have seen. Okay. Now we will see some questions based on rotational motion. See, a rigid body acquires angular speed of 100 radian per second after undergoing angular displacement of 600 radian in 12 seconds. Find what is angular acceleration and initial angular velocity. See what data is given. First of all, a rigid body acquires angular speed of 100 radian per second, means it is final angular velocity, that is omega. It is 100 radian per second. After undergoing angular displacement means theta. Here it is 600 radian. In 12 seconds, time t is equal to it is 12 seconds. So yes, you have to find two questions. Alpha is equal to what? And omega 0 is equal to what? Okay, how to find? Yes, you are given this omega, you are given this theta, and you are given this t. You have to find two questions. What is alpha and what is omega 0? So first of all, we will try to find what is omega 0. Okay, how to find this omega 0? Yes, we have one equation, that is theta is equal to omega plus omega 0 divided by 2 into t. Yes or no? Yes, angular displacement is equal to average angular velocity into time. So therefore theta, it is 600 is equal to what is omega? Yes, omega is this 100 plus omega 0, you have to find, divided by 2 into t. T means this 12, t means it is 12. Okay, simple. So it is 2. Here it is 6. 6, here it is 100. Okay, so yes, how to find now this? So therefore 100 is equal to it is 100 plus omega 0, and therefore omega 0 is equal to 0. Means initial angular speed is simple. Okay, now second question, you have to find alpha. Okay, how to find alpha? So alpha is equal to omega minus omega 0 upon t. Yes, omega is equal to alpha is equal to this omega minus omega 0 upon t. Then how to find this? See, alpha is equal to omega. What is omega? Here it is 100 minus omega 0, that is 0, and t means here it is 12. T means here it is 12. Okay, so therefore alpha is equal to it's 100 divided by 12. Is 100 divided by 12 radian per second square. It is radian per second square. Yes, it is value of alpha. It is value of alpha. Simple. Okay, so yes, you have to understand which data is given and which equation you have to use. Now next question is, see what is next question? Here it is. Initial angular speed of a wheel is 20 radian per second. Initial angular speed of wheel is 20 radian per second. Initial omega 0, 20 radian per second. Its angular displacement is 10 seconds. Its angular displacement in 10 seconds is 100 radian. So t is equal to 10 seconds. Angular displacement is 100 radian. How many revolutions or rotations will it make from the beginning to time till it stops? Initial angular speed is this, means initially it is in motion. You have to find numbers of revolution will it take from the beginning to time till it stops. Means as it stops, final angular velocity omega is equal to 0. Clear about this? So as it stops, its final angular velocity becomes 0. Omega is equal to 0. Okay, so you have to find what numbers of rotation and alpha. To see, first of all, from this data we can easily find what is alpha. So yes, alpha is equal to omega minus omega 0 upon t. So therefore alpha is equal to omega 0 minus omega 0 means it is 20 radian divided by t means here it is 10. So therefore alpha is equal to it is minus 2 radian per second square. So yes, first question is this. Yes or no? Yes. Now you have to find how many revolutions will it make from beginning to time till it stops. How to find this numbers of rotation? See, angular displacement is 100 radian. Angular displacement is 100 radian. See, in this lecture, okay, we have discussed, okay, for one rotation, angular displacement is 2 pi radian. See, for one rotation, angular displacement is 2 pi radian. So I can write reverse statement, that is, if angular displacement is 2 pi, then numbers of rotation 1. Simple. If angular displacement is 2 pi radian, then numbers of rotation 1. So for angular displacement 100 radian, numbers of rotation, yes, you can easily find the numbers of rotation is equal to 100 divided by 2 pi. So is equal to, it is 50 upon pi. It is 50 upon pi. Clear? So this is an easy question. You have to understand language. Okay, what you have to find and how to find. Clear? So yes, this is it for today.